afternoon, everybody. This is Bill Gentz with TopSolid USA. We were expecting a few more people to sign on here, so I'm just going to give it a few seconds here. This is the fourth webinar for today on what's new in TopSolid for version 7.16. So again, for those of you that haven't been part of these webinars today, I'm joined by Joe Hart, our technical manager. He'll be answering questions, so whatever questions you guys have, launch them out there. He'll do his best to answer them, or he'll direct them to me. And we're also joined by Mike Kay, our sales manager. Alrighty, let's go ahead and get started. So in this afternoon's webinar, we're going to mainly talk about sheet metal and unfolding. This one's going to be a fairly quick presentation, 10-15 minutes. Just some key elements to discuss on this. And then we'll recap with what's going to be happening tomorrow. Okay? So let's take a look at some sheet metal and unfolding new features and improvements. So first things first, a new contextual command allows you to apply sheet metal tubes and standard profile recognition to imported geometries. Why do you care? Well, you import a design, and the design is made of sheet metal parts and standard extruded components, maybe I-beams, hollow square tubing, and whatnot. And you need to manufacture, and most importantly, you need to document these things. So let's have a look. So if I go into TopSolid here, I'm going to minimize that one. So if I hover on this one here for a second, you'll see it's just a little step file. So I'm going to convert the document, nothing special. We'll let it go ahead and do it. And here's my part, okay, or my assembly. So you can see there's some hollow extrusions in there. There's some sheet metal looking parts in there. So we want to identify these so that we can create a bill of material and document these. So how do you do that? Well, I'm going to go here to all my part files, and I'm just going to shift select all of them, right mouse button click, and under sheet metal, I'm going to launch into my sheet metal recognition command. One of the things I'm going to be sure to activate here is the to identify tubes and standard profiles. You see a little bit of what's what here. Remember that these are all live previews whenever you click on them, so you can rotate, pan, and zoom to see what they are. Okay? We're going to go ahead and hit go. Green means good. That's done. Now, what did it actually do? So if I go to this thing and open it by itself, this is now a sheet metal part. Okay? If I go to this one here for this beam, you can see it added a frame, and it's provided the beam function so that it knows what it is. From there, we're going to save once. Let's go make a bill of material real quick here. We'll say extruded bars for manufacturing. Why not? Just to show you a couple things you can do. And then we'll go do some multi-draft from this. I don't need you. And I think, let's see, I think that's correct. Let's find out. I'm going to create all my drawings, and like that. Now you got some dimensions on there. You have some interrupted views on there. You have the beginnings of the manufacturing process started. So again, it's just the ability to take data that's created elsewhere, organize it, document it, and get it to manufacturing inside of TopSolid. Okay. Let's close everything there, and let's go back. All right. Well, I jumped ahead on this slide because I just did this one in conjunction with that. The whole idea there is part of that recognition allows this to happen, which is to orient automatically the views of these standard profiles so that the documentation just happens effortlessly. As well, in work documents, which I'm not going to go much into work documents during these webinars. I'm going to plan a webinar specifically for work documents for later on this year. A work document allows you to assign work to be done or processes to be done, okay? And we've added sheet metal recognition as part of the processes that can be done by a work document. A work document could also be used, for example, to automatically position a part to manufacture, apply some tool path to it, create the G code, create the setup sheets, and boom, spit it out, okay? So again, later on this year, I will do some webinars specifically tailored towards work documents and give you guys examples of how to use them. Right, moving on. We spent a good amount of time working on performance improvements. We had some customers around the globe that worked on some pretty big sheet metal parts. And when I say big, it's not necessarily size, but it's what's in the sheet metal part itself. So for example, one sample was a part that had 525 holes in it and had over 32,000 unique edges. Okay. And when we want to create the flat pattern for that, well, it took some time. So the modeling side in 715 was 7 minutes 30 seconds. Now it's 6 minutes and 24 seconds, so 13% faster. Going after the sheet metal properties, assigning sheet metal to it, went from 15 minutes down to 1 minute 10 seconds, 93% faster. The unfolding went from 14 minutes and 30 seconds down to 1 minute 18 seconds, 91% faster. You get the idea. We spent a lot of time. Over here on this sample, 205 holes with 1,542 edges. Again, modeling was from 4 seconds to 3 seconds, 25% gain. Sheet metal properties from 3 seconds to 0.45 seconds, 85% gain. Again, the idea here is we're always continuously working on this product. We're always trying to make it faster, more efficient for you guys. So this is a great example of us just showing that we're putting the effort in to make a robust solution for you. Alrighty. Next, unfolding and rebending of a bend. So we've always had the ability to unfold and refold a bend, but it had to be a bend. Okay? So in this case, when we want to unfold something that's not really a bend, it's more of a forming, for example. It's not really a forming either. It's just somewhere in between all of that. We had to make a command for that. Okay? Where this is ideal for is, unrolling a spiral staircase for stringers or for central stringers. So if you look at the image here on the right, you got the support beam that's kind of going up and around a corner. And we want the sheet metal to be unrolled so that we can make it more decorative, whatever, and then re-roll it around that profile. So I'm gonna kind of show you a couple of samples of this live. I just will attempt it. Let's see what happens. So first, let's look at the conical sample. Okay. And in my conical sample, let's do this. I'm just going to, you know what? Let's get rid of these 3 features. Okay. So I'll roll back, walk you through it. I made a cone, right? I'm using the Alt up and down arrow keys to step through this. I removed the top and bottom face. I did sheet metal by thickening, and then I created a slot to break it so that it could be open, right, or unrolled. Now, from here, if I go to sheet metal, I can go to the unbend of a bend. I'm going to choose my fixed edge here and my inside face, for example. And you're going to see it unrolls nicely. And from here, we can do whatever we want. For example, I'm just going to make a quick sketch here, and I'm going to say, how about if we go here, 1 inch, sure. We're going to throw a couple of different things in here, just to be different. Perfect. We can trim all by that. So now we got some Swiss cheese going on. And now we're going to go back to sheet metal, and we'll go back to rebending of a bend. We're going to choose our fixed edge. We're going to choose our flat face. And boom, like that, our Swiss cheese has been re-rolled, maintaining the exact sizes of everything. Okay, so this is an example on a conical face. Let's take another look. How about a helical sample? And not just a helix, a tapered helix, because again, why not? It's just to show the way the solution works. So I'm just going to roll back. I'm not going to do this one live. So we have our sheet metal, right? So this is just, as you can see, an extruded profile turned into sheet metal, which then I unbend. Okay. Again, same process on the unbend. I select a fixed edge. I select the inside face to unbend. I created a series of sketches. I created a trimming operation, and I repeated the trimming operation so that I have a hole going around there. And then I re-roll it, and everything's maintained. Okay. Perfect. And if we look at transition parts, and if you guys aren't familiar with the transition parts, maybe I'll take a second to talk about them. Here, I'll go back one more step. If I go to sheet metal, we have something here called transition sheet metal parts, where you can choose what the top section is, the bottom section is, to try to make a sheet metal for ductwork that is transitioning from round to square or whatever. Okay, so it's just a nice little bonus tool that's included. So we have our transition part from round to square in this case. All right, again, I had to split it so that we could create a flat pattern for it. Then we go to unbend it, and I'll go edit the unbend so you can see. So choosing my fixed edge, right? So in this case, I chose the outside edge in this front face, and I chose other bend faces to unflatten. I could add this one to it if I wanted to, and unroll that. Doesn't really matter. Okay, we could add that one. Just unfold and unfold. Now, once that's done, I just made a little rectangle, trimmed it out, and then rolled it back up. Okay, so unbending, and rebending developable bends is now significantly simpler in TopSolid. Cool. All right, I believe this is the last point. Like I said, this one's a short one. Here, we're going to talk about just a quick little new option to orient the flat along the longest length. As you can see by my pictures here, we had this simple little sheet metal part. When we unfolded it before, sometimes it would orient it like it is here, and you have to screw around with it to get this result so that you get a cleaner calculation for the amount of material needed to make this part. So what we did is we just made it simpler. Okay, so if we go to here, we open up our part, and we'll just go ahead and do this one live. So I'm going to go to unfolding, template necessary. I'm going to change to be bending on that face. And for example, I'm going to leave it in its, predefined positioning, the default. Okay. No, not that. I'm sorry, I want this one, like so. Now, this is showing you exactly what I was talking about. So now if you try to calculate a piece of material around there, you're going to get a huge wasted piece of material. So instead, it's a new option, and you can set this by default. Orient along the longest edge, right, or the longest length. Now, it will orient it always the longest length relative to the x-axis of the document. So that now you get a nice clean orientation to allow for the smallest possible material for waste. Cool. All right, that's it for sheet metal. So obviously, any questions? Before we go with questions, just to recap tomorrow's plan. Tomorrow we're going to continue with the TopSolid design sessions. So at 9 a.m. and 11 a.m. we have a few more items to cover. If you haven't registered for those, please do so. Then in the afternoon tomorrow, we're going to hit up TopSolid tooling to see what's new in TopSolid split, mold, progress, and strip design. And then we'll end tomorrow with the first bit of news about TopSolid Camp. Awesome. Does anyone have any questions on any of these new sheet metal features? If so, type them in. If not, have a great afternoon. Thanks for attending, and we'll see you guys tomorrow.